Alright, this is where we left off in our last video. So we solved this pair of simultaneous equation using the usual elimination method. Now let's look at the Gaussian elimination method for this same pair of equations. Let's rewrite all of this over here. Let me see now. I could just copy it and put it over here instead of rewriting it. Alright, so we have all of these things here. This is the set of equations that we had solved in our earlier video, in our previous video. Now, what you're going to do is rewrite these in matrix form. Alright? You have 2, 3, 4, 5 in matrix form. You would have x, y would be equal to 28, 50. Now, what we're going to do next is to make everything a bit neater. You know that what you have on the left are all multiplied by x. And you already know that what you have on the right, they multiply y. So, yes, you don't really need this x and y business here. Alright? Now, here, you have these numbers. What you do? Remove the equal sign. You want to separate the left-hand side of the equation from the right-hand side. When it comes to the equal sign, what here is on the left, what here is on the right. To do that, you draw a vertical line. Alright? So this is our vertical line. And you write these numbers here. You have the 28 and the 50. So, this is what we have here. Now, this is called the augmented matrix compared to what we had before with the three different matrices, the equal sign and the x and y's, right? The word augment means to add to or to strengthen, right? So we've augmented the matrix. So these are the augmented matrices. Now, instead of equation 1 and equation 2, let me shift it over a bit. What we have are row 1 and row 2. We're not going to bother to write the ROW. Just write R1, R2. Alright? Now, the aim is to have this in what is called row echelon form. The word echelon means to rank or to put in a certain order. For example, talking about persons in the upper echelons of society, looking at a class or a rank, it means the upper class. Right? Now, what you're going to have is a case where you have a number x plus a number y plus another number z. No, x and y we're dealing with. And say number 1 x, number 1 y equal an answer. call it A1. Then we have a 0x, no x, plus number 3y equal A2. You eliminated x when you do this. Alright? You would have eliminated x. So this you might consider row 2 as having a higher rank than row 1 because more work was done on row 2 because you eliminated one of the variables. So you're looking at echelon or classes of the amount of work done on each row. Row echelon form. Now, remember, we had multiplied equation 1 by 2. Now, instead of equation, we say row. We'll know that this is already 2x plus 3y. You have 4x, 5y equals 28 and 50. Alright? You just get rid of the x and the y and all the equal signs and so on to make it much cleaner. Now, what you're going to have is the way they usually write it is 2 row 1 will lead to our new row 1. So you're going to change up everything and have a row 1 changed. Now, row 2 will not change. So you say 4, 5, oh, I should have some space here. You have the line and you have 50 because row 2 will not change, only row 1 you will change. So you want to multiply row 1 by 2 is the same thing as multiplying equation 1 by 2. Later on, you're going to subtract one equation from another. Or you can consider it as taking one row, multiplying it by -1 and adding it to the next row. It's the same thing. You subtract. Right? Just like when you say A minus B. It's the same as A plus -B. You take B, multiply it by -1 to make it -b and add them. If you want to consider addition only instead of subtraction. But what happened? Here, when you have 2 times row 1, you're going to have 2 2's. You multiply this by 2, you get 4. New row. But in Gaussian elimination, you don't call it a new row because each matrix you have will only have 2 rows. So you keep calling it row 1, no matter how it changes. Row 2, you still keep calling it row 2, no matter how it changes, because there are only 2 rows. 3 times 2 is 6. 28 times 2, what is it? 2, 8, 16, 6. 2, 2, 4, and 5, 56. Alright, so you have 56 here. Alright? Now, notice now, your aim is to get a 0 down here. So when we rewrite this, you want a 0 to come here. Alright? So, what you're going to do is to say row 1 minus row 2 will give you a new row 2. So write down row 1, it will not change from here. Remember, row 1 had changed from this matrix to this matrix. But row 1 will not change when we go from this matrix to this matrix. Alright? So we have 4, 6, and 56. See that? Then we want a 0 here. So what we do? We say row 1 minus row 2 gives us a new row 2. 4 minus 4 will give us 0. So now we have our 0. Exactly where we want it. Then 6 minus 5 is 1. 56 minus 50 gives you 6. Now notice 4, 6 and 56. Alright? 4x plus 6x equals 56. You have 0, 1 and 6 in row 2. Equation 2, 0, 1 and 6. So you can see how they correspond. Now, since we have a row with only one unknown, we can easily get what the answer is. So let us rewrite it as equations. Alright, so this is 4x plus 6y equals 56. So that's what we have here. And then we have a 0x plus 1y equals 6. Okay? Because you know, both 4 and 0 are multiplied by x, both 6 and 1 multiplied by y, and 56 and 6 are on the right hand side of the equal sign. Now, since x is 0, you can see that y is equal to 6. Then you substitute here for x plus 6 times 6 equals 56. So for x plus 36 equals 56. For x equals 56 minus 36 equals 20. So divide by 4 and you get x equals 5. Alright? So Gauss had come up with this method, and it's called the Gaussian elimination method.